Hey everyone, welcome back for another deep dive. You know how we love to really get into the nitty-gritty of all things cybersecurity, and well, today's topic is something that sounds kind of deceptively simple at first.
It does, doesn't it? Format string attacks. I mean, how dangerous can those little placeholders in code really be?
Right. Like you see something like hello percent and think, oh, that's just going to get filled in with someone's name.
Right.
But turns out, well, they can actually be pretty dangerous, like weaponized even. And here's the really wild part. This isn't just a problem in one specific programming language.
Yeah, you're talking C, Python, Perl, PHP, Java, Ruby, heck, even Bash. I mean, the list goes on.
That's a lot. And that's what makes this so interesting, right? It's like this vulnerability is kind of universal. It transcends these individual languages. So the big question is, how do these seemingly harmless little strings become like a hacker's best friend?
Well, it all comes down to how these strings can be manipulated to actually change how a program displays information. Think of format string functions like instructions. They tell the program, hey, take this data and display it this way.
Okay, so far so good. But where do things go wrong?
The problem arises when an attacker can actually control the format string itself. That's when they can start injecting their own malicious instructions.
Gotcha. So it's not the language itself that's inherently flawed, but the way these strings can be misused. If I'm following you correctly, this can lead to some pretty serious consequences, right? Because, like, our main source material for this deep dive, a whole book dedicated to this vulnerability, keeps mentioning reading and writing to memory as the really dangerous outcome. What exactly does that mean?
So picture this. An attacker injects a special format specifier like %sex into the string. Now, this tricks the program into revealing memory addresses. It's like handing them a map to the computer's memory.
Uh-oh, that doesn't sound good.
Nope, not good at all. Suddenly, they have the ability to peek into the computer's memory and potentially find sensitive information. Things like passwords, financial data, all sorts of stuff you don't want them to see. It's like giving them the keys to the treasure chest.
Wow. Okay, so the stakes are definitely high here. And the book really hammers home the point that this isn't just some theoretical vulnerability. I mean, it dedicates entire chapters to explaining how to actually exploit this across all those different languages we mentioned.
It really does. It gets pretty technical.
But what I find fascinating is that it doesn't just dwell on the doom and gloom. There's a whole section on protective measures, too, which, thank goodness.
Right, because it's not all hopeless.
So let's shift gears a bit and talk about solutions. What are some ways developers can fight back against these format string attacks?
Well, one of the most crucial steps is input validation. Basically, this means really carefully checking any data that a user inputs before actually using it with a format string. Think of it like a filter. You only want to let in safe data and block anything that looks suspicious.
Makes sense. You don't want to just blindly trust anything that comes in from the outside world, right?
Exactly. And another key strategy is to avoid letting users actually provide the format string themselves. If the programmer defines that format string, it significantly reduces the risk of an attacker being able to sneak in something malicious.
Right, because then they have no control over it.
Yeah.
And I know there are other tools developers can use too, like those safer functions designed to handle data without these vulnerabilities.
Exactly. There are functions specifically designed to avoid these vulnerabilities. For example, instead of using, print, which is known to be exploitable, developers can use a safer alternative like printfs. It basically has built-in protections.
So we've got input validation, avoiding user-supplied format strings, and using safer functions. Okay, sounds like programmers have some options. But why should all this matter to our listeners who maybe aren't programmers? I mean, how does this actually affect them?
Well, the book has this whole chapter dedicated to real-world examples, and it really brings this home. Think about those data breaches you hear about all the time in the news.
Oh, yeah.
A lot of times, format string attacks are a contributing factor. They can lead to all sorts of havoc, from stolen information to system crashes, and even worse. It's a big deal.
So this isn't just a problem for techies. It's something that can impact everyone, even if we don't necessarily understand all the technical details.
Absolutely. Security is everyone's responsibility.
It really makes you think. With so many different languages vulnerable in this similar way, what does this say about how we, as a society, I guess, approach cybersecurity? It's almost like a pattern.
Yeah. It's a really good question. It kind of highlights the need for a more universal approach to security, right? Like thinking beyond specific languages and looking for these underlying patterns of vulnerability.
Definitely. And I guess that leads to something for everyone listening to think about. Whether you're a programmer or not, all the tools and technologies we use every day are built on code, right? I mean, it's the foundation of everything. So
Yeah.
are there hidden vulnerabilities lurking beneath the surface? We don't always know.
Nope, we don't. And that's kind of the point. It's about awareness.
Exactly. So maybe this deep dive will inspire you to do a little digging of your own, see what you can find, and maybe even explore some resources for more secure coding practices. You know, regardless of what field you're in, you can contribute to a safer digital world.
Absolutely. Even just being aware of these vulnerabilities is a huge step in the right direction.
It really is. Well, that's about all the time we have for today. Thanks for joining us for another deep dive. We'll see you next time.
See you next time.